In this tutorial, we will be demonstrating how to monitor performance for both active and historical sessions within your virtual desktop environment using the VDI ToolKit. So what performance is monitored? Well, CPU, memory, disk, BLAST protocol, PCoIP protocol, and RDP protocol are monitored. Now, please keep in mind that when connected to a virtual desktop session, only one protocol will actually be being used during that session. So with CPU performance, let's talk about what's monitored for CPU. So we have processor utility, user time, privilege time, and interrupt time. The definitions for those are processor utility is the amount of work a processor is completing as a percentage of the amount of work the processor could complete if it were running at its nominal performance and never idle. User time percentage is the percentage of elapsed time the processor spends in the user mode. User mode is a restricted processing mode designed for applications, environment subsystems, and integral subsystems. Privilege time percentage is the percentage of elapsed time that the process thread spent executing code in privilege mode. When a Windows system service is called, the service will often run in privilege mode to gain access to system private data. Such data is protected from access by threads executing in user mode. Interrupt time percentage is the time the processor spends receiving and servicing hardware interrupts during sample intervals. This value is an indirect indicator of the activity of devices that generate interrupts, such as the system clock, the mouse, disk drivers, data communication lines, network interface cards, and other peripheral devices. These devices normally interrupt the processor when they have completed a task or require attention. Normal thread execution is suspended during interrupts. This counter displays the average busy time as a percentage of the sample time. Now let's talk about what we monitor with memory. With memory, we monitor available megabytes, used megabytes by processes, committed megabytes, committed percentage, paging file used percentage, and pages per second. Available megabytes is the amount of physical memory in megabytes immediately available for allocation to a process or system use. It is equal to the sum of memory assigned to the standby, cached, free, and zero page lists. Committed megabytes is the amount of committed virtual memory in megabytes. Committed memory is the physical memory which has space reserved on the disk paging files. There can be one or more paging files on each physical drive. Committed bytes percentage in use is the ratio of memory to committed bytes to the memory commit limit. Committed memory is the physical memory in use for which space has been reserved in the paging file should it need to be written to disk. The commit limit is determined by the size of the paging file. If the paging file is enlarged, the commit limit increases and the ratio is reduced. Pages per second is the rate at which pages are read from or written to disk to resolve hard page faults. This counter is a primary indicator of the kinds of faults that cause system-wide delays. It includes pages retrieved to satisfy faults in the file system cache, usually requested by applications, non-cache mapped memory files. Paging file use percentage is the amount of the paging file instance in use in percent. Now let's talk about what we monitor with disk performance. So with disk performance, we monitor idle time percentage, queue length, seconds per write, seconds per read. Let's go ahead and define those. So idle time percentage reports the percentage of time during the sample interval that the disk was idle. Average disk seconds per read is the average time in seconds of a read of data from the disk. Average disk seconds per write is the average time in seconds of a write of data to the disk. Current disk queue length is the number of requests outstanding on the disk at the time the performance data is collected. It also includes requests in service at the time of the collection. This is an instantaneous snapshot, not an average over the time interval. Multi-spindle disks can have multiple requests that are active at one time, but other concurrent requests are awaiting service. This counter might reflect a transitory high or low queue length, but if there is a sustained load on the disk drive, it is likely that this will be consistently high. Requests experience delays proportional to the length of this queue minus the number of spindles on the disk. For good performance, this difference should average less than 2. All right, so now let's start talking about some of the protocols. So we'll talk about the BLAST protocol and what we monitor with that. We monitor frames per second, the round trip time, packet loss percentage, and jitter. Frames per second is the frame rate measured in frames per second. Round trip time is the time in milliseconds for round trip time from client to virtual desktop. Jitter is jitter for uplink in milliseconds and is the variation in the delay of received packets. Packet loss is the network packet loss for uplink in percentage. Now let's talk about PCoIP performance metrics monitored. So we have frames per second, round trip latency, RX packet loss percentage, TX packet loss percentage. So frames per second, again, is the frame rate measured in the frames per second. Round trip latency is the time in milliseconds for round trip time from client to the virtual desktop. RX packet loss percentage is the percentage of received packets lost during the sampling period. And TX packet loss is the percentage of transmitted packets lost during the sampling period. Lastly, we have the RDP performance, which we monitor frames per second, round trip time, user input delay, and packet loss percentage. Frames per second is the frame rate measured in frames per second again. Round trip time is the time in milliseconds for round trip time from the client to the virtual desktop. User input delay is the maximum value for queuing delay across all user input waiting to be picked up by any process in the session during a target time interval measured in milliseconds. Packet loss percentage is the loss of packets in percentage. So let's talk about why our charts are ugly. And okay, so that is a strong term. So they aren't necessarily ugly and we take pride in them. So let me elaborate what we mean by that. First, we believe data should be represented as it presents itself and should be unadulterated. So what does that exactly mean? Well, it means we use no smoothing algorithms on our charts, such as rolling moving averages, etc. Many other companies, when providing charts, are so worried about making them pretty, they modify the data with smoothing algorithms. You are in essence not seeing the true representation of the data when such algorithms are used. This can lead to thinking there isn't a problem when there actually is one. We choose to focus on a true representation of the data versus a pretty representation of the data. We believe this will equip you with better tools to make better decisions within your virtual desktop environment. Up next, we will demonstrate how to monitor performance for both active and historical sessions using the VDI ToolKit. Okay, so let's go ahead and get started. Once you open up the management console, it'll bring you here to the active sessions. We can actually, if you highlight over this icon here, you see view performance metrics. You can view them there. And you can also go to historical, and with your historical sessions, view the performance metrics as well. So I'll go ahead and click that. Now this is nice from a perspective that you have historical metrics you can easily go and see, because let's say a user was having issues or complaining about their virtual desktop session at a particular date and time. You can easily go back and see their sessions, search their sessions in the historical sessions, and then view what the performance is. So right here we have our CPU metrics. If you highlight your mouse anywhere over, you'll get the display telling you what the metrics are at that specific location, as we could see here, and the time. You can also take, and if I left click and hold and highlight an area, I can zoom in to a particular area. If I double click, it'll bring it back to the normal view. If you'll notice there's an ellipsis down here at the bottom. If I highlight my mouse over, it'll bring up, I can show grid lines. I can also show the legend too, and remove items that I don't want to particularly see in this scenario. I'll go ahead and add those back and hide that. So we have the CPU metrics here, which is the processor utility, user time, privilege time, and interrupt time. If we come to memory here, we can see here that we have the paging file used, percentage, committed percentage, committed megabytes, used megabytes by processes, available megabytes, and pages per second. And you can once again do the same thing and highlight over and then get the details on that. And same thing here with showing the legend or the grid lines. Next, we have disk. You can highlight over disk. You can see those items as well. And once again, it's the same things as before with the charts themselves. Now, under protocol, we'll notice here that this was a straight blast protocol session. So from beginning to end, the clients that were used to connect to it only used blast protocol, nothing else. Now, please keep in mind, though, that let's say I connected from one device using PCoIP, then another blast, and another RDP. You would see all those metrics from each time they reconnected to that session. So you would be able to see those metrics. Once again, it's the same thing. If you highlight over, you can actually drill down too. And I can double click and go back. This comes in real handy. Frames per second, it might be, hey, why are we getting that information? Why is that important? Well, if they're doing heavy stuff like, and you can test this out yourself just by opening up a YouTube video in your virtual desktop session and making it full screen, when the screen is changing often, it increases the frame rate. Well, the increased frame rate is going to lead to more bandwidth, and it could lead to some lagging and things like that. So you can get an idea how they've been using the virtual desktop, because if they're just using it for basic Word, PowerPoint, Excel, things like that, and they're a low to moderate worker, chances are you're not going to see high frame rates. The other nice thing too is with the round trip times on all the protocols. So the round trip times give you an idea how long it's taking for the client to actually get to the virtual desktop. And this is important because anybody that's had a virtual desktop environment knows that performance can be affected by network latency. And one of the big things is that when we have people connecting remotely, because on our own network, right, our internal network, we should know what's going on. We should have guaranteed low latency. But whenever they're outside our internal network and they're connecting from home or airport or somewhere else, a hotel, who knows, you can't control those factors as a network engineer, or a systems engineer. So for that, you're able to kind of see what was going on. That way, hey, somebody tells you the virtual desktop environment was acting terrible, you go and look, well, where were you? Because there was so much network latency, no wonder you were having issues. And also with the packet loss and things like that, it'll tell you as well too. That way, hey, you were on a really bad or poor network connection. So that pretty much sums it up with the performance metrics. You can also, just so you know, you click this shortcut, but you can also right click and hit view performance metrics as well too. Well, I hope you found this tutorial useful, and thank you.